It's 10:30, so I'm going to start. I hit record. Welcome to class today. I am going to, okay, I'm recording. That's awesome. I have to bring up the chat because I forget and share my screen. Oh, and what I really should do is turn off my video. Look, it's right there. Yep. All right, that's where I'm at today, guys. Welcome to class. 2 more lectures. I do have both of them posted in the skeleton notes if you want to start looking those over also. Today we're going to be talking about general integration formulas for the inverse trig function. So the same functions we had yesterday, only now we're going to do integration. So previously we saw that the derivative of the arc sine is 1 over square root of some stuff, and the derivative of arc tangent is 1 over adding some squares. And the arc secant has a u down here, usually in absolute values, but it kind of gets switched around sometimes. So why are there only 3 integral equations? Because even though we had 6 of the derivative functions, they were only off by a negative sign, right? We only had to memorize 3 of them. So we just take the positive pair and we only have 3 anti-derivative formulas. Now here's some tips that I use to help me remember which one is which. No square root for tangent. We have constant minus variable under the square root for sine. And this is horrible notation. I should be writing these out instead. And it's actually arc sine. And underneath the radical, we'll actually have a variable. And then notice it's a variable minus the constant. So the order is really what gets my notice here. The square root in the denominator, it can be confusing because sometimes this variable matters and then sometimes we just kind of poof it away. We'll see an example. So as long as you recognize the order of the subtraction, you know whether it's sine or secant, variable always being u. So constant minus variable, variable minus constant, they're squared. And the tangent just doesn't have a square root. So that's how I kind of keep them in mind. But I'm going to be honest, I also have them written down right next to me so I can look them up every time we need them. All right, here we go. Let's do this first one, leaving the formulas up. When I look at this format, I see that it's definitely not tangent. It looks like because there's no variable on the outside, this is going to be an arc sine. Arc sine of u over a plus c, but we have to figure out what our u and our a's are. 26, if I want to write it as a perfect square, that happens to be the square root of 26 squared minus x squared. So it looks like my a value is the square root of 26 and my u value is x. So my du is dx. So I don't know why I wrote this in the worst place possible. Using our formula here, we see that this will equal the arc sine of u, which is x, over a, square root of 26 plus c. Arc sine is the only of the 3 of the inverse trig functions that do not have a 1 over a coefficient. So it doesn't involve the a anywhere else other than inside the argument. And that's it. That's the end of this answer. So what this section is a lot of identifying what's my a, what's my u. So get number 2. Oh, you know what I forgot to do? Oh, there it is. I'll pay attention to the chat, I promise. Find the indefinite integral. Notice again, we have a constant minus a variable, right? They're both squared because anything can be squared because we're algebraic geniuses. So what I'm going to do is I know that a squared equals 81. Let me write down the formula again for us, just over here on the side, so we can see exactly where it's coming from. The integral of du over the square root of a squared minus u squared. Okay, so I'm looking at a squared is 81. It's taking the place of 81, which makes a equal to 9. We see our variable is being taken up by x plus 9. And so our derivative of u is just dx. So this becomes that 8, that's just 8. Let's bring that 8 over here. 1 over, and now we've written it as a squared minus u squared du, which according to the formula is 8 arc sine of u over a plus c. I should have done this on the first one. Reverse your substitution. That's an x plus 9 over 9. I'm just replacing our u here inside the arc sine. So it's totally formula driven, and it's how can we get it into this format the quickest? All right, and the most straightforward. So 1 and 2 happen to both be sines. One is a straight up, where the u substitution is just u for x. It's basic. But here we have a little bit of work to do because our u is an x plus 9 instead. All right, I'm going to take a drink in case you're still writing or entering the answer on your problem. Now let's look at number 3. Find the indefinite integral you see for the constant of integration. So when I look at this, the first thing I notice is no square root. So probably arctangent. So we write down the formula for the arctangent. That's going to be du over a squared plus u squared equals 1 over a arctangent of u over a plus c. Don't forget that plus c. I just kind of ran out of space there. So what does this mean? Remember, addition order doesn't matter, whether it's a squared plus u squared or u squared plus a squared. We're going to take the variable as the variable substitution and the constant a as our constant. So regardless of order, because it's addition, I know that this will be u squared and this will be a squared. So a squared is 49, u squared is 2 to the 4th. This makes u t squared and a is 7. It'll always be the positive value. We assume the positive square root because we're using arctan and we're not using arccotangent. But now my du is 2t dt. I have my t dt. I don't have my 1/2. So now my integral becomes the integral of t over t to the 4th plus 49 dt is the integral of 1/2 du. So I took care of the t and the dt. And I have 1 over u squared plus a squared, which is 1/2 times 1 over a arctangent of u over a plus c. And most of you will just not even write this step anymore. You'll just get to the point where you're at 1/2 times 1/7 arctangent of t squared over 7 plus c using my substitutions. And we'll rewrite this as 1/14 arctangent of t squared over 7 plus c. So these are our substitutions where we go in and bring it back out. All right. Let you sit with that one for a minute. One of the things you're going to learn here in 5.7 and 5.8, we're going to be substitution masters, and you're going to need that a lot in Cal 2. Some of the substitutions you do, it's going to be how can I play algebra games to make this calculus easier? All right. We doing all right? Oh, I don't need to see that. What do I need to see? I need to see that. I don't need to see that either. Nobody chatted. All right. I'm going to assume that's a yes because no answer is as good as me. This is when I check to make sure I have my speaker on. Okay, I do. So we're good. All right. Number 6. Wait, really? I completely skipped this problem when I was doing all of the problems ahead of time. Oh, no. No, I did this one. I know I did. Oh, yeah, I just numbered it wrong. Okay, awesome. Now we're going to evaluate a definite integral. So we're going to still use our substitution twice, but this time we're going to change it both at the beginning. Maybe, maybe not. Let's see. I have a variable on the outside and a square root where it's a variable minus constant. So my best guess is this is the arcsecant form. And that's 1 over arcsecant of u, absolute value of u over a plus c. That absolute value is absolutely necessary. If you have a t squared, you won't need to use the absolute value. But if you have just a variable like x, you'll absolutely want the absolute values because well, the sign will tell you you're wrong. And it has to do with the derivative, right? That derivative having an absolute value in the denominator. So it looks like my u squared is 16x squared, and my a squared is 3. So u is 4x, and a is square root of 3. 4x. Huh. Well, here's what we can do, and I'm going to temporarily leave our limits off. So, no, let's do this. No, let's not do this. Let's figure out where I am before I start talking. Find the derivative of u. There we go. Now, we don't have a 4dx, and we know we could offset that 4, but we also don't have a 4x. So check out this little trick. I can make this a 4 over 4. I haven't changed the problem, right? 4 divided by 4 is 1. X square root of 4x all squared minus the square root of 3 squared dx. Right? I haven't changed a thing. I still have my x in the denominator. I still have the square root of 16x squared minus 3 underneath the radical. I still have my 4x, but I've written it in such a way that I now have 4x, which is a u, and I have 4dx, which is my du. So when I do my substitution, this becomes du over u square root of u squared minus a squared. So by multiplying by just the right thing, this 4 over 4, we've been able to match up this form exactly so that we can rewrite this as 1 over a, so 1 over the square root of 3, arcsecant of the absolute value of 4x all over square root of 3, not plus c, because this is a definite integral, but since I've taken it back to x, Now I can evaluate from 1 to 6. And when I do this, this absolute value of 4x is necessary. But this 1 over square root of 3 is then going to multiply by the arc secant, put in 6. I'll get 24 divided by square root of 3 minus arc secant. When I put in 1, I get 4 divided by square root of 3. And I really should have parentheses here as it's the argument of the inverse secant. And then we'll round this to 3 decimal places. Let's see what that'll look like on the calculator. I'm going to put it over here. No, I'm not. I'll put it over here so it's off the page. Let's worry about that 1 over square root of 3 later. I don't want to put the whole thing in the calculator at once because this is really hard on my head. Okay, so arc secant, arc inverse. Secant is the reciprocal of cosine, so that's going to be 1 divided by the inverse cosine of 24 divided by the square root of 3. Come out of the radical, close that parenthesis, and then we're going to subtract the same thing, arc secant, so that's the reciprocal, or 1 over 1 divided by the inverse cosine of 4 divided by the square root of 3. Come out of the radical, close that parenthesis. Oh, it doesn't like it. It doesn't like it at all. What's wrong with that? All right, so let's do this instead. Let's find a calculator. And oh no. See if we can do it here. 1 divided by cosine inverse of 24 over square root of 3. It doesn't like that at all. Why doesn't it like that? Okay, but no. Let's check it out. This is number 6. Yeah, I'm having a good time here. It's legit. That's what my answer was. My dogs are about to go nuts. Because I still had 6 but I just can't calculate it. It's right. I can't calculate it and I don't know how to round that. So let's do this instead. I mean, without a calculator, I don't know how to round that. So let me try this. Let me try 1 divided by, oh no, it has to be a number. I can't answer anything else in there. So find a calculator, make it work. Or we know what the exact value is. Parentheses, there they go. Mailman just got here. Square root of 16x squared. Of course, we would never use a graphing utility in this class. Minus 3. No, what's up here? There we go. Okay, let's graph that. Oh, that's ugly. But we can still calculate this integral from 1 to 6 217. But you know, you should absolutely do it this way. Wait, let me say this appropriate. If it's going to be this challenging to enter our answer onto a calculator, I mean, back in the day, we'd have to use tables. So we'd have to find a book that had a table of the values. And we'd have to estimate what 24 over square root of 3 was, because, you know. But my goodness, find a way to enter that. The calculus is way easier than the calculator sometimes. I'm gonna stop that problem right there. Okay, and I'm also gonna make me go away. Number 9. So it's correct. I swear it's correct. But I didn't practice on the calculator. Use a specified substitution to find or evaluate the integral. All right, so it tells us use u equals the square root of x minus 3. All right. Well, then the derivative of u is 1/2 x minus 3 to the negative 1/2 dx. And we can rewrite that as 1 over 2 square root of x minus 3 dx, which also, notice, that's u. So du is 1 over 2u dx. Let me see what we got here. So we can start this out with the square root of u over x plus 8 dx. But there's u and x, so we need more subs. So we know that if u is the square root of x minus 3, then u squared plus 3 equals x. Oh my goodness. Tuesday's got a case of emotion off today. If the u is the square root of x minus 3, square it, add 3, and I can replace my x. So that's u over u squared plus 3 plus 8 dx. But we don't want a dx. That's a bummer. All right, we have to substitute more. I don't have a 1 over 2u, so let's multiply that. 2u du equals dx. All right, so we will have the integral of u over u squared plus 11 times 2u du, all in u. So now we can do some work. Ready to calculus. That's not how the word's used. Now, in order to actually, let's take a breath. Are we good on this? Does this make sense that for the given u, we would need to find the derivative of u, and we can then solve for dx. As we slowly make substitutions, the u is cool. We still have an x, so we need more substitution. So we can put the u squared plus 3, right? We can figure out exactly what x is. U squared plus 3 plus 8, but the dx needs substituted. So we found what dx was equal to, and we finally got everything substituted. It took 3 steps, but we're there. Now check this out. Here's another instance of adding 0 multiplying by 1, also pretty clever, like we did up above, multiplying by 4 over 4. Here we're going to add 0. So we have the integral now, u squared plus 11, and we have a 2u squared up in the numerator. So what we're going to do is I'm going to add 22, and then I'm going to subtract 22. Because if I add 22, and I subtract 22, I haven't changed it at all, right? It's like multiplying by 4 over 4. But what good does that do? Check out this, and I'm going to need more space here, so we'll get more space here in a minute. I'm going to separate this as 2u squared plus 22 over u squared plus 11 minus 22 over u squared plus 11 du. All right, now let me gain some space here. No. Oh, that was almost bad. All right, here we go. All right. Okay, so let me review again. All right, once we made our substitutions for u, nobody spoke up. Nobody had a, you know, hey, what's going on here? Everybody good to here? Fantastic. Okay, so now I'm going to add 0. How do I know to add 0? Because I'm a math professor. How do you know to add 0? Because you've taken this class and you're learning it. Why did we want to add 0 like this? This 2u squared plus 22, I can factor out a 2. So this becomes 2 u squared plus 11 over u squared plus 11 du. And we can simplify this. I'm doing this in as many steps as a step monster could do. Okay. Now, this seems reasonable, right? Like, okay, if we have this, obviously we could do that. Obviously we could do this. U squared plus 11 divided by u squared plus 11, that's just a 1. This as the form of the arctangent, where u is equal to u and a is equal to the square root of 11. So we have, oh, come on. We're not going to write the integral of 1. You guys are better than that. This is 1. What has derivative 1? U does. Minus 22 times. We can recognize our arctangent form. A is the square root of 11. So we'll have 1 divided by the square root of 11. Arctangent of u over square root of 11. Don't forget plus c. And then we bring it all back to where it first started. Slowly scrolling. Come on, there we go. And we have 2 square root of x minus 3 minus 22 over the square root of 11 arctangent of the square root of x minus 3 over the square root of 11 plus c. If you wanted to, you could simplify under a single radical if desired. But that's our answer, right? And that's a good one. And that's where you're going to have to get creative, super creative. I'm going to scroll up in just a minute. Let me give you a second to catch up on your writing. All right, so I'm going to go for the slow scroll so I don't freak out your eyes. Right here is where we multiplied by 4. Now multiplied by 1. Add 0 by adding the 22 minus 22. So these are truly tricks of a mathematician. I had a professor once tell me something that was pretty awesome. He said, whereas math students see an X, mathematicians see a 1 times X plus 0 to the power of 1, right? Because the X is never just an X. We can always add 0 to it and it doesn't change it. We could always multiply it by 1 and it doesn't change it. And it's, already raised to the power of 1. So we got to keep that in mind. And once you no longer see this X and you actually see the opportunities and how you can add 0 in creative ways like plus 22 minus 22, or how you can multiply in 1 in creative ways like 4/4 that help you out, that's when you're like, ah, cool, I'm a mathematician. It's all right to be a math student for right now. Some of you are already getting pretty close to surpassing me, and I think that's awesome. All right. Now, the last problem always seems to be a hard problem, so I decided to do it, but this one is not. It's actually what makes it difficult is how trivial it is. And it's only trivial if you know one piece of information. And it's like, seriously, why is this on here? Okay. An object is projected upward from ground level with a velocity of 660 feet per second. From level ground, it's just upward. It doesn't look like it has an angle. Velocity is 660 feet per second. That's initial velocity. But what we have to keep in mind always with projectiles is acceleration. And I spelled that wrong. Due to gravity. When they start making pens and pencils and whatever this is, with spell check in them instead of on the program, that would be awesome. Okay. Acceleration due to gravity is minus 32 feet per second squared, or minus 9.8. Is it 9.81 or something? Meters per second squared. Mathematician, I use 9.8. You physicists, you go ahead, use whatever number you want, but pi is not 3. All right, this matters because in order to find the velocity, we must first start with acceleration. And acceleration is constant due to gravity. Gravity's pulling on that sucker. It's the only thing that's pulling on that sucker because we ignore air resistance. So our velocity is just the antiderivative of acceleration. And we know that that's 32t plus c. But our initial velocity is 660. So c equals 660. That's exactly what that constant is, right? If v sub 0 is at time 0. So if time is 0, this whole thing is equal to 660. But if time is 0, that goes away and it must be c is equal to 660. And so we have our equation. We could probably write it correctly and put the t where it goes. 660 is the constant, and then I put minus 32t. There's two reasons I did this. One, because when I checked my answer to make sure it was that easy, that's how WebAssign had it. But the second reason I put it like this is because we frequently misplace negatives that are out in front. If they're inside the equation, we're less likely to mess them up. Don't get me wrong, we can still do that, but less likely. So the position is now the antiderivative of velocity. And we know how to take this antiderivative. This is 660t minus 32 times t squared over 2 plus a constant. But it starts at ground level. Initial height is 0, which tells me that our equation for position is 660t minus 16t squared, 32 divided by 2. And that's why our projectile motion problems involving feet and seconds is always 16, right? Make minus 16 for the coefficient of the square. It's due to acceleration due to gravity and the units. So that was the last question, and it's really as easy as the points indicate. So don't overthink it. They give you all of the information you need here, which is kind of cool. And it's kind of cool how we see these coming together. And really, for me, I think this is why, like, these types of problems are a lot of the reason why mechanics, physics 2320 and 2321, which so many people in the College of Science have to take. You need to know this and understand that in order to excel at physics. All right, that's all I have. So, how are we doing? Do you have questions? It's 11:05. Good. Fantastic. Here's what I'm going to do. I'm going to, fantastic. I'm going to stop the share. I'm going to hit save. Stop sharing my window. We could just talk. I'm going to also stop the recording. I'll pause.